What is it? Is it hydrolase? Is it transferase? You can ask like that way, then see what remaining. Is it oxidoreductase? Are you having any oxidation reduction here? No, it is not oxidoreductase. It is not transferase. It is not. Is it isomerase? It is not isomerization also, right? Because we are having two molecules. One molecule is giving two molecules. So it is not isomerization. Is it? We just said it is not transferase. So then what is it? Ligase. Ligase needs ATP, energy required synthesis. Are we using any ATP to have the energy? So it is not ligase. Then what is remaining? What is remaining? Only one enzyme is remaining. What is that? Lyase. Lyase. Right? So the class of this enzyme is going to be lyases for the aldolase. And now what would be the subclass? Under lyases we have dehydrase, we have carboxylase, many enzymes under lyases. Lyases, remember I mentioned it's a big family of enzymes. Anything does not belong to those enzymes is actually under lyases family. Lyases is the open. It takes everything in this family. So aldolase, here you can see that the two molecules are attached. That's also telling the lyase is that when two molecules are attached together, that is the lyase, and this will be synthase enzyme. Appropriately, we can call it the synthase because it is not dehydrase, it is the synthase molecule. Synthase subclass is going to be synthase for aldolase. Now look at that. What is the relationship between these two? One we are calling the dihydroxyacetone phosphate, another one is the D-glyceraldehyde 3-phosphate. What is the relationship between these two? Do they have different number of atoms? If you count, you will find the same number of carbon, same number of oxygen, same number of hydrogen, same number of phosphorus in both molecules. So they are having same molecular formula. If they have the same molecular formula, what we call them? They are constitutional isomer, remember? They are isomer, but the constitutional because they have different functional group. What is this functional group? Ketone, and what is this functional group? Aldehyde. So we are having two different functional groups. So they are two isomers. This isomer, the aldehyde form, that is the D-glyceraldehyde 3-phosphate, that can directly enter to the next step. But this dihydroxyacetone phosphate that cannot enter directly into the next step. It has to now change. That dihydroxyacetone phosphate has to change to D-glyceraldehyde 3-phosphate, which we call is the step number 5. So for the step number 5, this is the substrate. Substrate is the dihydroxyacetone phosphate, and the product is the D-glyceraldehyde 3-phosphate. So that what is happening then? This is the two are isomer. Then what we need? What type of enzyme we need? An isomerase. Because this is the isomerization reaction. So the enzyme that is responsible for doing that one, that isomerization, we call it the triose phosphate isomerase. Triose, why this is the triose is coming, remember? 3 carbon chain and they are all carbohydrates. 3 carbon chain carbohydrate, we call them triose. Because they are isomerizing the 3 carbon chain carbohydrate, that's why the triose coming, and the isomerase because this is the isomerization reaction. So ketone will convert it to the aldehyde. So now, how many D-glyceraldehyde 3-phosphate you are getting from one glucose? One glucose is giving us 2 molecules of D-glyceraldehyde 3-phosphate after step 5. So now, from now on, whatever reaction is going to happen, we need to consider that they are happening 2 times for each molecule of D-glyceraldehyde 3-phosphate because we are having 2 molecules of D-glyceraldehyde 3-phosphate. So we need to multiply by 2 for every reaction if we want to count that how many products are forming. And another thing that we need to consider here, I forgot to mention here, the first step ATP is the energy rich molecule. As I mentioned, that ATP is the money for our body. We are doing some business. So here is the investment, first investment that we are having. So we are spending some money, ATP. Remember, this pathway, our target is to get more ATP, but instead of getting ATP, we are spending money here. But that is true, like in the business, if you don't spend money, you don't earn money, you don't get money at the end. So that's the investment we are doing here. One molecule of ATP is invested here, and another molecule of ATP is invested here. So two molecules of ATP invested so far up to step up to this point. Two molecules of ATP invested. Now from there on, we are going to see our return will start to come. So then the next reaction here, which is the step 6, the substrate is the diglyceraldehyde 3-phosphate, and the product is the 1,3-bis-phosphoglycerate. So what is happening here in this reaction? Look at that. What is this one? NAD plus and NADH. What is they are doing? What is the NAD plus? An oxidizing agent. So do you expect that means an oxidation reaction is happening here? Because an oxidizing agent is here, that is converted to the reduced coenzyme. So what is happening? What functional group is this one? Aldehyde. Look at the product. What functional group we are having? Aldehyde is converting to the carboxylic acid derivative. Are we oxidizing them? Because do you remember that? How the carbon change the oxidation? So here carbon changing. If we oxidized, alkane can convert it to alcohol. Here carbon oxidation number for carbon is 0. Here oxidation number is -1 for the carbon. Sorry, +1. Because it is attached to one electronegative atom. So this is -1 we consider, this is +1. The charge at the end is the neutron. Second oxidation product for the alcohol. If we oxidize alcohol, what we are going to get? An aldehyde. So alcohol, aldehyde, and what is the oxidation number for the carbon here? Here we call the oxidation number for carbon is the +2 because it is bonded with the oxygen 2 times. Then if we further oxidized aldehyde, it is going to convert to another oxygen will come now, carboxylic acid or derivative. That one, what is the oxidation number for carbon? 1, 2, 3. 3 oxygen attached, so it is the +3. Then finally, if we oxidize the carboxylic acid, that will give us CO2. Carbon dioxide, where +4. Opposite is thus the reduction. So carbon can have maximum oxidation number, carbon can have +4. So that is our target. We are going to convert our every carbon to this way, +4. So here, this aldehyde now, we are here, aldehyde is now oxidized to carboxylic acid derivative. So that's what the change you can see by looking at the reaction. You should be able to say that what is happening. Aldehyde is the carboxylic acid derivative, so that is oxidation. And for the oxidation, we need NAD plus because NAD plus is taking away hydrogen from this carbon. This hydrogen is taking away, and an oxygen is attached. and the NADH, this is converting to that form. And what enzyme is needed? The enzyme for step 6 is the glyceraldehyde 3-phosphate dehydrogenase. So what is the class of dehydrogenase enzyme? Oxidoreductase, right? It is oxidoreductase because that family, and dehydrogenase is a kind of oxidase because it is doing the oxidation reaction. That is the subclass for the dehydrogenase. Dehydrogenase, removing hydrogen. So the next step. So we have now 1,3-bisphosphoglycerate. Now look at that, what is happening. Now we are producing the ATP molecule. We are not investing here. Now we are starting to synthesize ATP. And what is happening? One of the phosphate group that is attached to that carboxylic acid group, that is being now transferred. This phosphate group is now transferred to the ADP, and ADP will convert it to the ATP. So again, we are transferring a phosphate group from one molecule to another molecule. So it is a transferase enzyme and kinase. The kinase that is responsible for doing that one is the phosphoglycerate kinase. The next step for this one, after having the 3-phosphoglycerate, now what is happening? Look at the molecule. This one to this one. What is the change? If I ask question from this glycolysis, I will not ask you to write the reaction, chemical reaction. I will give you the reaction, but you need to analyze your reaction. Like for example, this reaction is given, and here is the question mark. What would be the enzyme, or what type of reaction it is? So I don't want you to remember that what is the step 8 that is transferring that one. I will probably mention this is step 8 and that is the reaction. So now look at the reaction, what is happening. Look carefully, that phosphate group was here. In this carbon, which is the carbon number 3, because this is carbon number 1. 1, 2, 3. Now that phosphate group from here, it is going to carbon number 2. See, just changing the position. What type of reaction it is? An isomerization reaction, because it's just rearranging atoms within the same molecule. So for that, we need isomerase enzyme. And isomerase enzyme sometimes called as the mutase. So mutase is also an. This one is the phosphoglycerate mutase. That the family of this one is the isomerase enzyme. The next one is now happening. Oh, up to this point, what we can consider? How many ATP molecules actually synthesized here? Remember, I mentioned that from that point we need to multiply everything by 2. Are you getting 2 ATP molecules? Because these will be 2 of them. So we are getting producing 2 ATP molecules. How much we invested before? We invested 2 ATP molecules at the beginning, right? Now we are generating 2 ATP. Is it now, balance sheet is clear now? Whatever was invested, the ATP molecule, that is now returned completely. 2 are invested, 2 are produced. Now from now on, whatever we are getting, that is our benefit. All the ATP that is going to be synthesized. Up to that point, it is, the balance sheet is now equal. So the next step is step 9. So now look at that, what is happening. It's converting to that one, this carbon becoming a double bond. Can you tell what type of reaction we are having here? Remember this reaction. and if we have some catalyst like sulfuric acid and heat this reaction, what did we form? An alcohol, this OH and this H, that come as the water, and carbon-carbon, they form carbon-carbon double bond. We learned this reaction, now that reaction is coming here. This reaction we call is the dehydration reaction. Dehydration of alcohol gives us the alkene because it loses hydroxy group from one carbon and a hydrogen from the adjacent carbon and produce carbon-carbon double bond and give us the alkene. That's what is happening here. So this alcohol, this OH and this hydrogen, they are combining to form water. That's why the water is coming out from the molecule, and as a result, we are forming carbon-carbon double bond. So it is a dehydration reaction. So the enzyme name is the dehydrase enzyme. That is the subclass, and what is going to be the main class? Dehydrase under lyase family, right? So it is a lyase enzyme. So this is now, we call this one is the phosphoenol pyruvate. So we are almost to the pyruvate because this is just the isomerization that we need to have now. So that is what is happening. At the same time, we need to transfer that phosphate to the ADP, and we are producing another molecule of ADP, and it is getting rearranging because it is the enol form of the ketone and converting to the ketone. This carbon is now becoming ketone. So that is the final molecule, pyruvate, and this reaction is catalyzed by pyruvate kinase, which is a very important enzyme for this entire process. All this glycolysis, where it is happening, we know that inside the cell. Is it happening in the mitochondria or cytoplasm or cytosol? Where is it happening? Glycolysis takes place inside cytosol, not in the mitochondria. For the mitochondria now, this pyruvate that will enter into the mitochondria. And how much pyruvate will enter into the mitochondria, that will determine this pyruvate kinase. Pyruvate kinase is also known as the gatekeeping enzyme. That will tell that how much pyruvate should enter into the cell. In the cancer cell, this pyruvate kinase does not work. In the cancer cell, and that's why we get the cancer. If this pyruvate kinase does not work properly, we get cancer. So we are going to learn, so this is after this is the glycolysis. Then next week we are going to learn that what is the fate of the pyruvate, what would happen to the pyruvate next.